Assalamu alaikum, I'm Rabita Junhai. So for this project, we'll have to first create an environment. In order to do so, we'll have to add a background and background light. We can do so by clicking on the plus sign and going to proto nodes, then selecting objects. From there, we will go to the background, and from the drop down, we'll choose textured background and textured background light. For background, we have choose an empty office, and for background light we have chosen the mountains. Then we will have to add floors. We can do so by clicking on the plus sign and going to proto nodes again and objects. From there we'll choose floors. From the drop down menu we'll choose the floor solid. Once the floor has been created, it will be visible in the left panel. From there we can set the color of the floor by going to diffuse color. So we have set all the values to 1 so that we get a white floor. Now we will have to create a robot. In order to do so, we'll have to click on the plus sign again, but select base nodes this time and choose the robot from the options. Then in the children of the robot, we will select the bounding object use body and add physics to it. The next task is to add a hinge joint. So we can do so by clicking on the plus sign, going to base nodes, and from here we'll choose hinge joint option. Once the hinge joint has been added, we'll go to it, and then we'll go to the joint parameters. Then from there we'll choose device. Now for device we'll be choosing rotational motor so that the robot controller can generate rotational motion around its hinge axis. Then in the endpoint null we'll set it to solid. Once this is done, we'll select the PBR appearance so that we can change, and here we can also change the color. The geometry of the wheels have been set to cylinder. The height and radius are set to 0.02 and 0.04 respectively. We have used the bounding object use wheel, and we have also added physics to the wheels. Now this will be repeated for the rest of the 3 wheels since the robot has 4 hinge joints. Thank you.
Assalamu alaikum. My name is Nabila bint Hassan. For our line following robot, we need infrared sensors to detect the track. So after creating a robot, we went to the children option. We added, from the base nodes, we added distance sensor. So inside the distance sensor, we changed the translation, rotation, and the type as infrared. Then we renamed our sensors accordingly. So there's 3 sensors here, left, right, and middle. We positioned the sensors a little bit outward so that it allows proper reading. Now for our line following robot, we need to import a track. To do that, we went to Tinkercad and we used the scribble option to draw a path like this. Then we adjusted the color and also the height, and then we exported it as an object file. So in VBots, we selected the option of import 3D model, and then we imported that object file we got from Tinkercad. And this is the track we have. Then we aligned our robot to the track. Now let's look at our code. Now for a robot to run, we need to put in a code. So to do that, we went to wizards and clicked on robot controller. In the first part of the code, let's see, from the controller, we imported the robot. Using the robot class, we created this object, created this time step to take readings every few milliseconds. Then we declared 3 variables. You can see that the distance sensor names, we matched it from here. Initially, we kept the value as 0. In this part of the code, we enabled the time step. For the motor names, you can see that there's wheel 1, wheel 2, wheel 4, which is also matched over here. And this part of the code, we again enable the timestamp and set the velocity as 0.
Assalamu alaikum everyone, I'm Mohsin Samin and I'm going to talk about the rest of the code. After all these parts, we are taking some global variables which are error, prop, integration, differentiation, kp, ki, and kd. The first 4 are set 0 initially, and the rest kp, ki, kd are set adjusted according to our robot for this track. Now we have also taken 2 methods which are PID and set speed, but we'll talk about this later. Then we are taking an infinite loop, and inside that we are printing the left and right values, and later we are taking the value from each of the sensors and calculating and looking at the values, and if either left or the right value is at 1000, it means that the track is rotating, so that means the robot has to rotate itself. So we are according to that we have created some cases if the left is greater than the right, or both of them is greater than 500 or less than 500. So according to that, we have taken the calculated the error that way. And yeah, once we have an error, we're sending it to the PID method. The PID method is using the global variables to calculate an adjustment needed for the robot to stay on the line, and returns that rectification, which is saved at the rectify variable, and then it is sent along with the speed to the set speed method, where each of the motors are speed as are adjusted. But if neither of the left or right sensors are equal to 1000, then it means we have to check for the middle sensor. If the middle sensor is at 1000, it means it is on the right path, and so we continue with the speed we have. But if it's not, that means the whole robot is outside the black line, so we have to adjust accordingly. So we are rotating the robot in its place in order to so that it can find the correct path. So that is all for our code. Thank you.